Ladies and gentlemen, let me introduce our research on the topic Intelligent System Visual Simulation of Passenger Flows done by Yurii Matseliukh, Myroslava Bublyk and Victoria Vysotska at Lviv Polytechnic National University. First of all, let's establish what is passenger traffic, what it consists of, and how it's formed. The basic unit of passenger traffic is the passenger. The grouped flow of passengers forms the passenger flow. The relevance is that currently the visual simulation of passenger traffic is important for understanding the construction of roads and their use by passengers. The purpose of this work is to improve the quality of passenger services by assessing passenger traffic on roads. The object of the study is the process of visual simulation of passenger traffic in public transport. The subject of the study is the principles of visual simulation of passenger traffic in public transport. This table shows the comparative characteristic of three similar software products. Each of them represents its specific market segment. For example, A plus C Ukraine is a company that only provides research and visualization of passenger flows but does not provide information on what software tools it used. On the company's website you can find only the screenshot of the type of visualization of passenger flows. Next is the site Texty.org.ua, which in turn provides information on e-tickets sold, but the latest data was updated in January 2019. The last in this list is the software product PTV Visium Germany, and it is an incredibly large and multifunctional tool for studying not only passenger traffic but also traffic, but this product has one of the biggest downsides, namely the price of 2 million UA hryvnia per 100 kilometers of the state road, and for example the length of the usual trolleybus road in Lviv is 12 kilometers. A more detailed comparative characteristic is given in this table. A general goal to visualize simulate passenger traffic on public transport roads. Aspect of the general goal: construction of dynamic and static simulation models of roads and application of mathematical models. Criteria: leaves a GTFS standard support, integration with Excel spreadsheets, intuitive interface, self-learning capability, and forecasting. An HP was used to select the system type. The slide shows a hierarchy of criteria and alternatives for system types. Alternatives includes intelligence system, search informational system, reference informational system. Criteria include GTFS standard support, integration with Excel spreadsheets, intuitive interface, self-learning capability, and forecasting factors. Most important criteria: interaction with data and working with models. General goal: choose a type of system for design. As a result, selected based on the result of expert assessment and matrices. It was determined that the best construction option is intelligent system. Intelligent system is most suitable for this project because data interruption, teaching, prognostication, decision support. Context diagram IDEFO functional diagram. The first level of decomposition. For example, IDEF3 diagram. Hierarchy of tasks in the form of a tree. The Python programming language was chosen as a mean to solve this problem. The main advantage was the large number of libraries, modules, and existing shortcomings were not significant for the implementation of this project. Of all the modules used in the project, the most important are the interface module and the graphical data visualization module. Among the interface modules, the choice was made between PyQt and Tkinter. As a result, PyQt was selected, the characteristics of which are given in the table. Among the graphical data visualization modules, the choice was made between Pygame and Pyglet. As a result, Pygame was chosen because it better supports 2D rendering and it's quite easy to use. The table on the right shows example of using two different SQLite and MySQL databases. As a result, following from the data, SQLite database is chosen for use in the given designed system. The slide shows the schematic of the database in which GTFS data is stored. The database is used in this project and contains certain mandatory tables, and this set is approved by GTFS standard. The project also used neural network to predict changes in passenger traffic on the road. An example of the structure of the neural network is shown in this figure, but the size of each layer is not static but depends on the input data. 5 data is fed to the input of the neural network, namely, how passenger traffic on the last race entered its worked capacity, and at the output we get the value of the new passenger flow. The slide shows the main interface of the software product. To select a road, click on the drop-down list of the road field. A view of the interface with the successfully selected road and its type of schedule. The Start on the Map button will start working in the On the Map mode. The Start button schematically will start working in schematic mode. After learning the neural network, the Visualize schematically button on the right side of the interface displays the result of the change. The map view is shown on this slide, and the feature of this mode are: first, traffic in both directions. Second, arrival of transport for stopping, disembarking and picking up passengers. Third, change the speed of the visual simulation, which is displayed as service information in the HUD in the lower right corner. Fourth, zoom the map and road, which is displayed as service information is HUD is in the lower right corner. 5. A vehicle that is on a launch brake. A view of the schematic mode is shown on this slide, and the feature of this mode are: a drop-down menu that provides information about the status of the stop is selected time period. A drop-down menu of the race, which provides information about the status of the load of the race and its parameters. The third, general information about the whole road. Red indicates segments in which passenger traffic has decreased or not changed, and green indicates increased passenger traffic. So at work they are. The key role of visual simulation of passenger flows to improve the quality of passenger traffic has been established. Functional diagrams IDEF0 and IDEF3 have been created. The choice of programming language for the project is sustainable. The development of an algorithm for dividing roads on the forward and reverse side placement of stops on the road, unique algorithms for visual visualization in map and schematic modes. Created a software product for visual simulation of passenger traffic in real conditions, forecasting changes in passenger traffic using a neural network. Thanks for your attention.